Guys, today we're going to talk about adapters, drivers, roaming issues, and you know me. I'm going to just base this on my experience here, 10 plus years of experience at Seven Signal and what we've seen. So I'm going to apply that experience, apply that knowledge in our presentation today. We'll talk a little bit about things that you can do, right? Things that you can do. Here are today's topics. It's really just a big three. We're just going to talk about adapters and drivers and what we're up against. That's a big one. Knowledge is power. You need to be empowered with what the capabilities and limitations are out there. Okay. And not a lot of people understand that, adapters and drivers are, very much separate things from, your APs or Wi-Fi networks. Two, we'll talk about measuring performance. And then three, finally, we'll talk about what we can do. When we bump into these issues, when we identify after measuring that we in fact have these problems, what can we do? What can we do? And then there we go. So here we go, guys. Here we go. So these are our little adapters. I grabbed some snapshots of some wireless LAN adapters off the internet here. Over here on the right, this is our Intel 802.11be, also known as Wi-Fi 7 adapter over here. Little guys, this is where the antennas go right here. You see these little nodes, if you can see my mouse up here in the upper right of the adapter, that's like the little leads for the antenna. And little guy, right? Over here on the left, this is an iPhone 16. iPhone 16 taken apart. And this contraption that you see right here that the guy has his little forceps on, it's actually the wireless LAN adapter antenna slash it's glued or attached to the earpiece to the part where, and so you can't split them apart. So it's like one piece of hardware that is attached to that actually performs two functions. Part of it is the Wi-Fi and part of it is the listening device. Okay. The point that I'm getting at here is that, hardware, this is tiny stuff. It's really incredible how powerful it is from a sensitivity standpoint. But antennas in these devices are tiny, which is why sometimes we're really concerned about, how far up in the sky are your access points in a warehouse? They're 80 feet in the air, or are they 30 feet in the air? It makes a big difference when we're talking about the receive sensitivity of these devices. These antennas are small. Okay. Now here's the other half. So layer one, right? We've got to get the particles, we got to get the waves out of the air. That's step one, and that's where the hardware comes in. But what's next? It's the software. Okay, let's talk about Wi-Fi drivers. What you need to know, guys, if you don't already know, and a lot of you already do, is that Wi-Fi drivers are proprietary software programs. Okay. And I've underlined and I've bolded and I've italicized the word proprietary. Okay. So Intel, they're going to do it the way they want to do it. Realtek, they're going to do it the way that they want to do it. Apple, they're going to do it the way that they want to do it. They're going to design or create or write a program, a software program that allows the operating system to talk to the hardware and interpret all of the data and information that's being grabbed out of the air, right? So, like I said, Apple, they're going to grab that information out of the air and they're going to interpret it and make decisions accordingly. Different than Intel, different from the other manufacturers as well. And you've got to realize that devices behave differently on Wi-Fi networks, and that's why, guys, it's so hard to design Wi-Fi networks today. You know this, because we've got more and more people bringing MacBooks into the environment. Why? Because they think they're cool, and actually they're really powerful devices. So I don't no knock on that. But what I'm saying is that it's a relatively new phenomenon where people want to have like their device that they want, that they're comfortable with. And what that does is it can cause problems in Wi-Fi environments. Why? Because Apple devices do behave very differently than Windows devices on networks. And you could say the same thing about Android devices. It's, remember, what are software drivers? They're basically the interface between the operating system right? Mac OS, Windows, Android, Linux, and the hardware, which is gathering all of basically the antennas and gathering all of that information, all those particles and radio waves out of the air. All right, so when it comes to drivers, what do they do? What are they responsible for, right? So I just said this. They're responsible for the communication between your operating system and the hardware, the wireless LAN adapter that we just looked at. What else are they going to do? They're going to scan. Okay, so Wi-Fi people will typically refer to this as probing, probe requests, then there's probe responses. We're going to scan for available networks. What's out there? What's all around me? Okay. Next, it's going to handle both wireless and security protocols. Okay, so the software has to say, okay, you know, what am I, is this A, B, G, N, A, C, A, X? What protocol are we using here? And then from a security standpoint as well, right? WPA2, WPA3, all of that is in the software with how to, you know, negotiate through all of that. Enterprise authentication, right? EAP, WPA2 and WPA3. Next, obviously, authenticate, establish the connection, manage the connection. And what do I mean by that? You know, based upon conditions, based upon the inputs, right, from the antenna, from the hardware, the inputs, it's going to go into that proprietary software, and we're going to be able to optimize the data transfer rates, right? MCS, based upon all of the factors, most importantly, RSSI or signal strength. Error handling is going to be in there, right? And based upon the error handling and based upon the conditions, we're going to negotiate data transfer rates or speeds, either higher or lower, based upon conditions. All of that's happening in the software. All of that is happening in the drivers, the Wi-Fi drivers of your computer or your handheld device. And it also is in charge of other things like power saving, right? Frequency selection. Another name for that is, you know, roaming, right? Because, you know, do I want to be on channel 36 or do I want to be on channel 1? Do I want to be on 5 gigahertz? Do I want to be on 2.4? Are there other options that are better over on channel 149? All of that frequency selection and all of that evaluation that's going on is all happening by the Wi-Fi drivers. Okay. And then the Wi-Fi drivers are going to say, hey, operating system, do this. Hey, operating system, do that. Okay. And then, you know, things are going to, and then it's going to tell the hardware, hey, hardware, you know, I want you to do this. I want you to do that. All right. All right. Now let's talk about the big chipset players. There's just a handful of them, guys. That's it. And number one on the list, of course, you know, is Intel. So Intel wireless LAN adapters. I mean, Dell, Lenovo, Microsoft laptop computers, obviously. Most Windows devices are going to be Intel chipsets and Intel wireless LAN adapters. Not all of them, but based upon what we know, and it's not public knowledge, but just when we look at our database, for example, which has, you know, millions and millions of data points in it, I would say approximately 70% of the corporate Windows laptops that we see out there have Intel chipsets, have Intel wireless LAN adapters, therefore Intel drivers, okay? Intel drivers. So they are huge player, huge player. All right. And I'm going to show you some things later on as to how you can kind of keep up with what Intel is doing since they are such a huge player. Now, when you get a new laptop, or let's say that you're procuring for your organization a lot of new laptops, we're going to buy 500 of them. We're going to buy 1,000 of them because it's now time to retrofit them. Okay. Intel Wi-Fi adapter is not going to be on the spec list. You don't know. It's just going to say Wi-Fi 6. It's going to say Wi-Fi 6E. It could be MediaTek. It could be Realtek. Okay, so these are some kind of less expensive options. So if you're trying to save a few bucks per laptop, and you look at these two laptops and you're like, well, which one? They look the same. This one's just a couple bucks cheaper. That could save us some money overall on a big order like 1,000 laptops. Lo and behold, one way that they try to save money is that it'll include a wireless LAN adapter that is either Realtek or MediaTek. Okay, so these are our Chinese friends. Overall they're fine, but they're not as robust, and those companies are not as on top of upgrading drivers as, let's say, Intel is. One thing that's good about Intel is that they do a great job of communicating when new drivers are available and what was changed, and I'm going to show you a little bit about that. Okay. Sometimes customers, like I said, they don't realize that their fleet is just this heterogeneous mishmash. They just think that everybody's got a Dell Latitude or Precision laptop, when in fact, inside, especially from a Wi-Fi perspective, the adapters and the drivers are just radically different. Okay. And so from a Windows standpoint, this is what we see a lot of: Intel, MediaTek, and Realtek. Then you've got Qualcomm and Broadcom, right? Now, you're not going to see a lot of that in Windows computers. Okay, they're really, their specialty is maybe more in the cellular end of things. However, Apple, for a very long time, was using Qualcomm and Broadcom technology in their MacBooks, in their laptop computers. But that's changing. Apple is now, because they've got chip manufacturing capabilities, right? Apple is now manufacturing their own hardware, their own wireless LAN adapters. So just like how they, kind of went away from the Intel chipset and they moved to like their M1, their own chipsets for CPU, they're doing the same thing with Wi-Fi hardware now too. Okay, so they're kind of leaving Qualcomm and Broadcom behind, and they want to do it all themselves. Okay, great. If you can kind of control your own supply chain, have at it. Have at it. So these are the players. These are the players. Okay, let's go to the next step. Let's talk about what we're up against. What we're up against. Remember, at the top, I said we need to understand the capabilities and limitations of these different chipsets. Okay, what's available to us, what is not available to us, what we can do, what we can't do. And that's part of what we're discussing today. So you could just go to, we post this stuff online, 7signal.com/info/ as you can see, clients and roaming. Go there. That's a good spot. But we're going to go through each one of these 3 links. I want to show you these resources that are available to you online. Guys, knowledge is power. You need to know what you're up against. People are going to challenge you when they say, oh, it's your crummy Windows computers. Oh, it's your crummy Apple computers. If you are armed with knowledge as to how these different systems behave by design, then it's really going to help you in your job. It's really going to help you when talking to others. All right, so let's go to this first one first. Boom. Okay, so this is online, and some of you may be familiar with this page. Gosh, it is so powerful. And to be honest with you guys, you need to study it. You should study it and memorize some information that's on here. So for example, I'm going to go down here, and this is a good one right here. So we're talking about, KV&R, really important. This is what facilitates roaming between access points. All right, so an adapter driver set is going to evaluate what is going on, and it needs to make a decision. Should I stay or should I go? Do I stick or do I roam? But when we roam, we want it to be smooth, seamless, and that's why these protocols are so important. Okay, they refer to them as assisted roaming technologies. And again, a lot of you out there are familiar with KV&R, and a lot of that is just built in today as well. What's really important, however, I'm going to scroll down to the bottom here. Look at this, guys. If you have an older Mac, you can see Intel-based Mac, they do not have KV&R. All right, so just keep that in mind. You have to know what the capabilities are. But rest assured today, if you go to the top of the list and you look at this, basically any new MacBooks that you have today with Apple Silicon, you're going to have basically the protocols that you need in order to ensure smooth, fast transition, smooth, fast roaming. Okay, that handshake, that 4-way handshake. It's going to be nice, and we're going to be able to transition nicely. Now let's keep going. Decisions to roam. Yeah, number one is signal strength, right? Now, Apple, obviously, it's proprietary software, so they don't tell us everything that goes into the decision. They tell us a few things, and that's what we're talking about right now. Here's another awesome table, guys, that again, you should get familiar with if you aren't already. Look at this. So MacBooks with Apple Silicon, the Roam trigger threshold minus 75. Okay, so if you're a Windows person, or if you've been to, and if you're a certified network or a certified Wi-Fi engineer, you know, um, an administrator or an expert or whatever, you look at that and you're like, how could they do that when they teach us to design networks for minus 65 or minus 67? That like just flies in the face of what we're taught. And minus 70, that's the trigger threshold. Don't even look until you get to minus 75. And then not only that, but when you look, okay, it's got to be 12 dB stronger, 12. So the older devices, and actually the handheld devices, it's 8 dB. Okay, 8 dB. But still, a lot of this, it might, to some of you, it might fly in the face a little bit with regards to, well, then why are they telling us if more and more MacBooks are coming into the enterprise, and in some environments, oh my gosh, guys, with our customers, I mean, we're seeing 50-50. Then how the heck are you supposed to design a Wi-Fi network? And I don't know if CWMP has, advice on how to design a network for both. I don't know. I mean, you guys should talk about it in the chat. How do you design a network for both when they behave so radically different? Tough. If maybe you've got 10% MacBook, then, you can get away with designing your network for minus 65. But when it comes to cell overlap and all of that, now the one thing that I will say, and you guys know that a lot of you are Mac users out there, is that even at lower signal strength or poorer signal strength, MacBooks are still able to perform quite nicely. I think you guys probably know that. Probably a lot of you people out there, with less signal to noise ratio, you're still able to have decent performance, and you guys can discuss that amongst yourselves in terms of your experience. But this is also really important to get your head around as a Wi-Fi person, as a network engineer, is understanding the differences. So that's why I'm bringing this up, guys. That's why I'm bringing this up. So this is a great thing. And then obviously the, other selection criteria, including band network and identifying roaming candidates. And there's some examples here as well. Okay. Now this is really important down here. So they're giving you some insights. Look at the center of the screen. They're giving you some insights with regards to preference. So what they're saying is that Wi-Fi 7 will be preferred over Wi-Fi 6, and Wi-Fi 6 will be preferred over, okay? And then down here, this is another good one. A 160 megahertz channel will be preferred over these other ones. So basically, you just need to understand this. You just need to know it. So, this could or could not cause problems in your environment. You just need to know what is going on in the mind of your wireless LAN adapter and the drivers that are governing it. You need to know what's going on. Okay. What else do we have down here? And then we just get into some nice definitions with regards to KVNR. You can learn all about it. Okay. Really good stuff that's on this page. Okay. Now, with regards to joining networks, this is another good link down here. And what they're saying is that the newest Apple devices will prefer 6 gigahertz over 5 gigahertz, and obviously 5 gigahertz over 2.4. And that may or may not be a good situation for you. It might be exactly what you're looking for, or because you're in charge of the enterprise, it might be messing up what you're trying to accomplish. It could go either way is what I'm trying to say. All right, let's go back. And now let's go to Intel. Intel. Like I said, Intel is the biggest player. Probably, according to our database, about 70% of all of the adapters and drivers out there are Intel. Okay. And again, we're back to our KVNR. Very important for that roaming transition, making sure that we can roam securely and nicely and quickly between access points, right? So here we go. This is really cool stuff, guys. Now, everything is obviously yes, yes, yes. They've had KVNR built in, protocols built in for a number of years now. But when I get to the bottom of the table, this is what I want to show you. Okay. I will also tell you that in our database, we see a ton of 7265s. We see some 7260s and even these little 3160s, which are maybe like little smaller devices, like maybe an Intel NUC or something like that. Sometimes they have those in them. The point that I'm getting at here is that you may not even know that your environment has legacy equipment out there with these 72 series adapters, and they are not KVR compatible, not depending upon the rev version that they are. So you need to be aware of this. You need to be aware of this. It's like, I know that networking people sometimes don't talk to device people and vice versa. And so sometimes there's a lot of finger pointing. It's like your devices are the problem. No, 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 it's your network. Your network is the problem. That's where obviously an organization like Seven Signal tries to help out because, we try to bridge the communication gap with technology, of course. All right. And then let's go to the last one that I wanted to show you. This is the coup de grace. Okay. And if you've ever been on training sessions with me, I will typically show you this web page because of how important it is. And that is the latest Wi-Fi drivers from Intel. And look at this, guys. They just released new drivers yesterday, 23.100. All right. So I am always checking in this page. I got to be honest with you. I think they're updating drivers. It seems like almost every month, every 6 weeks. Hard to keep up with. Hard to keep up with. And sometimes you don't want to keep up. I mean, if you're on a version that you're really comfortable with, and that's when we get into our second portion of or the second topic is measurement. But you may not want to go any further. You may want to wait before you upgrade. Down here, obviously, it's going to show you and tell you what is in the software package. So this new package is really all about Wi-Fi 7, is what it looks like to me. It's all about Wi-Fi 7 support. You can download the release notes over here on the right side of the page. Something else on this page that I really want you to pay attention to. I'm going to go down a little bit here. Okay. A lot of you don't have necessarily, the AX, 201s or AX 211 wireless LAN adapters in your environment. You've got older stuff. Okay, you got older stuff. Like for instance, right here, let me select this. We see a lot of 8260s out there. Okay, and we already talked about, the 7265s. The point is that it says from release 22.220 onwards, this software no longer includes drivers for this discontinued product. So, I mean, you could upgrade it to the 23.110 that just came out yesterday. It's not going to do anything for folks in your environment that have an older laptop with this older adapter in it. Okay, so you need to know. And then what they do is they provide a link to the web page that does have the latest version of drivers for that. But this is 22.220. They're not making any little tweaks and changes anymore for that. So I'm telling you this because, excuse me, because, up here is not always relevant to your fleet, especially if you have an older fleet, right? I mean, they'll upgrade laptops on either like a 3, 4, or sometimes 5-year cycle. So things can get really old in your environment. I mean, gosh, it's expensive to swap out 10,000 laptops. You do it over time and you do it carefully, right? All right, so that's the other thing that I wanted to show you. So that's what we're up against, guys. That's what we're up against. So how do we know what to do next? We have to perform an analysis. Okay, we have to, if we're going to measure performance, how do we perform an analysis? Here's an example of what the scan data looks like. So it starts with the scan data. What is your device able to hear all around it? Okay, this is just an example. Okay, what can it hear on 2.4? What can it hear on 5? The signal strength, the channel it's on, the channel width. You can see channel width, 40, 20. Okay, the vendors. Look at the channel. This is coming right out of the air, right? The QBSS. What's the channel utilization? Look at this on channel 6. Whoa. Channel 11. And then even when you get to channel 149, a 36% channel utilization, it's getting close to busy, right? So it's really, really interesting. Let me show you what this looks like. Okay, let me show you what this looks like. Okay, and then what we do is we take this information, which is basically the raw data, and it allows us to do an analysis so that we can measure performance, right? Signal strength, and then identifying every minute, minute by minute, the operating system it's just incredible how the operating system and the Wi-Fi adapter can communicate like this and basically make these decisions so quickly, all right? So what we can do is we can do these analyses of, okay, what's your signal strength? And what's all around you that's either available that you should be roaming to or not. And it allows you to then see, it's like, okay, is this adapter and is this driver roaming aggressively enough? Or are there little pockets when we do our measuring? Are there pockets where, for 1 minute, 5 minutes, maybe even 10 minutes, it's like we've got a driver here that's really making bad decisions. Okay, so you have to measure. And then if you add in this information, guys, okay, if you add in information about the device, oh, it's a Realtek adapter. Here's the driver version. Oh, it's Windows 10. Okay, here are the capabilities. Here are the spatial stream. When you add in this information, now you can generate reports that give you something like this. Okay, identifying poor performance in your environment. And I'll say it again, a lot of people don't realize just how heterogeneous the environment is. There are dozens of adapters and 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 multiple dozens of versions of driver. Okay. So you've got 22.220, 22.10, 22.80, 22.100, 23.4. I mean, guys, it goes on and on and on. This is just a snapshot from an analysis, but it goes on and on and on. And we wonder why our clients have spotty experiences. Well, why is it good for you, but it's not for me? Why is it that these people are having problems and those people aren't? Well, if you understood that clients are pretty much 50% of the equation, okay, and the decisions that drivers make are 50% of the equation here, pretty much, then it becomes something that you can then talk about with your device colleagues, or something that device colleagues can talk about with Wi-Fi networking colleagues. Okay. So this is pretty cool, and this is how you can do it in your environment. But you know what a lot of people ask us? They say, that's cool, Eric. Great. You've got, if you look on the right side of the screen here, you've got 10 clients who have this configuration. Yeah, and of course you can generate a list of them and you can see who they are, which is totally cool. But you know what, Eric? What about, that's my environment. Can you give us any guidance with regards to, the whole world and mass? Okay. And the answer is yes. Check this out. So 7 Signal has compiled this information in order to help you. All right. Consider it a public service. The idea here is that, yeah, en masse globally across, tens and tens of thousands of devices, we're measuring roaming performance, right? And we can identify proactively if there are certain adapter driver combinations that stink, okay? And you can then root them out of your system. And then you can also see, well, which ones perform optimally. And those are the ones that we should gravitate towards. Let me show you what I'm talking about here. Okay, so we're going to go here, and we're going to go to here. Okay. All right, so this is my Grafana dashboard. You should be able to see this here. And of course, these are the worst 10 up here. But down here, this is pretty cool, because down here, what we have is basically every single adapter driver combination that we've been able to discover all around the world. Okay. And look at the samples. Like, okay, we've got For the AX201 22.170, we've got 4.2 million samples. Okay? And then what we're doing is we're coming up with a percentage good roaming calculation. So it makes good roams, good decisions 97.6% of the time. And in our experience, based upon complaints and everything that's out there, you really have to be above 95%. Okay. That 5% is a big deal because it's just so random and people are having a good experience here, a bad experience there. It's kind of random. And so therefore you need to be above your adapter needs to be making good decisions 95% of the time. Otherwise, people are going to feel it. They're going to feel like randomly they're having these sketchy experiences. Here's the good news. There are lots of adapter driver combinations out there that are at 100%. Let me show you. Right here, good roaming calculation. Boom. Okay. So you can see the number of samples. And you can see, some of these are not huge number of samples, but as we scroll down a little bit, we will start to see that there are some combinations that have incredible performance. How awesome is that? Okay. Now, another thing you could say is like, wow, we've got a lot of 9560s in our environment. Which is the good one? Well, let's just go back up to the top here and sort by adapter driver. Okay. Let's just take this one, for example, the 3165. So you can see we've got good amounts of samples, and we can see that this one right here, this 1951 40.1 is at 100%, whereas all of the other ones are less than that. We can see down here that, look at this one, 203,000 samples, for this 18.33.17.1 for the 7260. We're at 99.8% roaming performance. Pretty awesome. Which one do you want to stay away from? Ooh, this one down here, 96.3, bad. Getting close to bad. Because remember what I said, 95% is really what we in our experience kind of feel is bad performance. And guys, it goes on and on and on. It's totally cool. It's totally cool. So per adapter, you can actually see which ones are awesome and which ones stink. Wouldn't it be nice to take this information to your device team and say, guys, we got some data here and we need to make data-driven decisions based upon these analytics. We should be getting laptop computers with this chipset, with this adapter, these drivers, because you know what? It's going to elevate everybody's performance and it's going to cut down on complaints. All right. And your life is going to be, and no more finger pointing. All right. We'll be able to get along. Hey, you know what? Let's have lunch together. Right. Just for fun, let's see which one has the most samples. I'm going to click on total samples. Boom. Boom. Look at that. 20 million samples for the Wi-Fi 6 AX201. Yeah, that's a biggie. The 23.60.1.2, and look for the Wi-Fi 6E AX211, okay, which is, kind of like its big brother. Same version of the driver, 16 million samples. So cool. And they're both at 99%. So that's got to make you feel good because a lot of computers today are shipping with these two adapters. Okay. By the same token, the 23.60, as we already know, is a little bit old. And what we would want to do is we'd want to sort the data by this adapter in order to see which versions stink. Okay. So for example, I could tell you that a lot of them down here in the 22.1, 140, 150, 160, 170, 180, a lot of problems. How do I know that? Because we have the data. Okay. Totally cool. This is fun stuff. Okay. You get the idea. So keep going here. Here, look at this one right here, for example. This is what I'm talking about. This is the Wi-Fi 6 8X201 with the 23.30 version. Almost 1 million samples in the bucket, and it's performing much worse than the other ones. Keep away. Stay away. Okay, next. Coming down the home stretch here, guys. Let's go back to our presentation. Here. I hope that was fun. and interesting. Now, as we come down the home stretch, when you have all of this information, all of this knowledge, you've partnered with companies that can give you cool analytics like we were just looking at. Now what? What can you do? All right. What can you do? A network redesign? Yikes. Oh my God. Are you kidding me? Well, depending on how old your network is, yeah, I mean, you might need to do the whole kit and caboodle, the whole shebang, and you're going to want to redesign it. Now, remember what we talked about a bit ago? We said, well, how do you do that if 50% of my clients are Apple and 50% are Windows? Good luck. I don't know. Okay. You guys should get together and discuss because I don't know the answer to that. Okay. But I will say this, that before you design a network, maybe those are some questions or some discussions that should transpire with different parts of the organization so that they just simply know what they're up against. And that was kind of like the topic, know what you're up against. Next. Okay. If you are an Apple owner and you want to improve the performance of your device, and are there things that you can do? Not really. Okay. So Apple shields, they abstract all of this away from consumers. They don't want you thinking about it. They don't want you worrying about it. It's their job to make a device that performs amazingly. And that's what they want to do. And that's their approach. And you know what? It's a pretty good approach. It stinks when these devices enter into the enterprise, just from the standpoint of, if you've charged me with making sure that devices all behave pretty much the same and have excellent performance on these networks with these applications and all of that, if you don't have a lot of little switches and dials to change settings, then again, there's not much you can do. But again, this should be part of discussions that you have with device people. It's like, look, okay, you want to have this, hot rod of a device, this new MacBook Pro, awesome, no problem. But when problems arise, let me just tell you that there are some things that we can and other things that we cannot do. All right, let's talk about Windows. Yeah, okay, so that's the good news, is that obviously, across our fleet, there's a lot of things that you can do with Windows device by going into the device manager. When you go into the device manager, short of replacing adapters and upgrading drivers. So let's just say that you've replaced adapters and you've upgraded drivers to the level that you want. and even after doing that, you can go to the device manager and you can go to your wireless LAN adapter right here and go to advanced properties. And you can do really cool stuff like prefer band, increase roaming aggressiveness. These are not perfect settings, but I'll tell you, we've seen them work. We have seen them work, where you increase the roaming aggressiveness of a whole fleet of devices in that building and performance improves. Now you got to make sure that the devices, actually have the KVNR and that, they can do the thing that they're of the right vintage, that they can take advantage of maybe, some of these protocols that we have. But this is really important stuff. And I have this little link here for PowerShell because we actually have some PowerShell commands that allow you to make changes to these things en masse remotely. So like Microsoft SCCM, Intune, Endpoint Manager, whatever they're calling it these days. You can create a little script. Let me show you that really quick. It's pretty cool. Where is that? Okay, right here. Okay, so in PowerShell, when you do a get net adapter advanced property, I mean, here are all the goodies that are available to you as a person. So like, remember, the topic of this is what can you do? So troubleshooting, we can actually see if your device is making good or bad decisions. Great, it's making bad decisions. Now what? With Windows, there are some things that you can do. Down here, this is what I was just showing you, is that you can set the net adapter advanced property roaming aggressiveness right here. You can set it and you can display it to the highest. And basically what you're going to do is lower the threshold, let's just say from -71 to -70. Okay, but that 1 or 2 dB can make a big difference in performance. Okay? And so these are some of the things that are available to you. that are available to you. So there you have it, guys. There you have it. Wanted to just share with you a little bit about adapters. Know what you're up against, capabilities and limitations. Not everything is a device problem. Not everything is a Wi-Fi network problem. Okay. Measure performance. Identify through analytics. What are the good ones? What are the bad ones? And then you can make decisions accordingly. If you're not in a position to upgrade or replace or fiddle with settings, okay, then, you know, if you're not in a position to do those things, then you know, there are options at your disposal. Okay, so let's go back to here. What can you do? And again, you know, some PowerShell commands are pretty handy. Android, let's talk about Android really quick. So for example, Zebra has something called the Wi-Fi. So with Android, there's something called the managed configuration. It's kind of low level, pretty deep, but you can actually pass in like these low level settings to the device. Like with Zebra, their OEM config, they have something called the Wi-Fi manager. And the Wi-Fi manager will show you, it's like, okay, modify the config of your fleet of Zebra devices to, you know, improve roaming aggressiveness, for example. Totally cool. Actually, let me show you that really quick as a last thing, because I think that that's really powerful. All right, let me go over here and find that. Where's the Zebra? There it is, Wi-Fi manager, boom. See this, guys? Okay, so what this does is it actually shows you, you know, there's all of this cool, and if I were to do a Control F, let's click Control F, roaming, there it is. Okay. There's some awesome roaming settings here. Set roaming RSSI threshold and delta values. Pretty important to know that, you know, if you've got these Zebra devices that you just spent a few $1 million on and you're like, what is going on? There are some things that you can do. Okay. So Wi-Fi manager in Zebra using OEM config, you know, work with your vendor. But there are some things that you can do where you can change these options. There are little switches and dials for Android devices. And I think SpectraLink has the same thing as well. I'm not sure about Honeywell, probably, but Zebra is such a huge player. And I was just and we have so many customers with Zebra devices. I was just so happy to see that they do offer you this documentation for when you need it. And there you have it. Okay, let's go here. And it wouldn't be a presentation without a thank you slide.